corrosion and rancidity. Okay. So before I start that, anyone has any questions in whatever we had studied so far?
Yes, sir.
Ish, what was your doubt?
Sir, example 5th one and 7th one, sir. Yes, sir.
What was your doubt?
Sir, oxygen is added to metal, no, sir. Then it must be addition to metal, sir.
Oxygen is added to
Metal.
metal. Okay. Oxygen can be added to anything. We don't care. If oxygen is added to something, any substance, then that process will be called as oxidation, right? We don't care what it is added to.
Okay, sir.
Okay, but since here we were learning the alternate definition, so remember that oxygen is also a non-metal. So if a non-metal addition of non-metallic substance, that is also called oxidation. Right? That's what we did, the addition of non-metallic substance, that is also called oxidation. So when oxygen is added, oxygen is a non-metal basically. So you can also write that over here. Addition of non-metallic substance, that is oxygen. That also gives rise to oxygen. That is also known as oxidation. Okay. Reduction part, it's clear.
Yes, sir.
Here also removal of non-metallic part. So if removal of non-metallic element, that is also called reduction. So as you can see, oxygen is getting removed here. So we can also study this as removal of non-metallic substance. That is also known as reduction. So we can see this reaction can be understood based on both the definitions, whatever we studied. This can be clarified based on the old definition also. Oxygen is being added here, oxygen is being removed. But this can also be understood based on the new definition. Addition of non-metallic element for oxidation and removal of non-metallic element for reduction. All right. So next one, 7th. This one.
Yes, sir.
Okay, tell me what was your doubt here?
Sir, sodium is added to oxygen, no, sir.
Sodium is added. See, the reactant is already there. No? Sodium is here. When this sodium came this side, what happened? Oxygen got added to sodium. No?
Okay, sir.
Yeah, that is true. In this case, in this part, oxygen is there and then sodium got added. That is why we are calling this as addition of metal to oxygen. So both ways, see, whenever we see a reaction, both the things are happening here. Sodium is also getting added to oxygen and oxygen is also getting added to sodium. So when we see it with this perspective, oxygen being added to sodium. Earlier it was sodium, now it became sodium oxide. So in this part, upper part which I am doing here, oxygen is getting added. That's why we are calling it as oxidation. But in this part, it was earlier oxygen. Oxygen is already there. What got added? Sodium got added. Sodium is a metal. So addition of metal is known as reduction.
Okay, sir.
Okay. Fine. Any other questions? Anyone? Okay, this one I had given as an assignment. So what happened here, guys? Explain, tell me. Where is the oxidation happening? Where the reduction is happening?
Sir, hydrogen sulfide becomes hydrogen sulfide is removed and iron is added.
Okay. Kavya, is that you? Kavya, your audio is not clear. Not able to hear you. No, your audio is very low. I can hear you, but I can barely hear you. So,
Now, sir,
yeah, now it's better. Yeah. Tell me.
hydrogen sulfide, sir, in the which becomes hydrogen plus iron. So it will be reduction, sir.
You mean
Addition of a
this one? Should I drop it here? From
yes,
here to
sir.
here?
Yes.
Okay. Everyone agrees?
Yes, sir. And
So what is happening here? Tell me explanation. What is, like I always tell you, know what got added, what got removed. Based on that, what is it? Oxidation or reduction? What is it?
Addition of a metal, so reduction.
Hmm. So you're saying that iodine is metal?
Oh,
Sir,
sorry, sir.
iodine is non-metal, sir.
Yes, iodine is on the rightmost side. Chlorine, fluorine, bromine, iodine, they are all non-metals, okay? Iodine is not a metal. But anyway, you see H2S is there. Is it not better to drop it over here? H2S is there. What is missing? S is there, but H is missing. Hydrogen is missing. So removal of hydrogen. Does it not explain it better?
Yes, sir.
So removal of hydrogen, what do we call it? Oxidation or reduction?
Oxidation.
Yes, removal of hydrogen, we'll call it as oxidation. Then it was only iodine here. Hydrogen got added to the iodine. So that should be a better explanation. Addition of hydrogen. And addition of hydrogen, what is it called? Reduction. So tell me all these, answer these 4 questions quickly.
Substance oxidized is hydrogen sulfide. Substance reduced is iodine, sir. Then
Yes,
oxidizing agent is iodine.
this will be, reducing agent will be hydrogen sulfide. Is everyone clear with this? Anyone has a doubt? Take a minute, spend some time and make sure you understand this also and these 4 questions also. Okay, so anyone has any other questions, let me know. All right, so we will move on to the next topic now. All of you do one thing. This one is not there in the PDF which I have shared. So take a screenshot and all of you make note of this in your tuition note. Okay. Take a screenshot. Make note of this one. Everyone has taken a screenshot.
Yes, sir. Yes, sir.
Okay. close this now. Let's get to today's class. So the topic, we are still studying chapter 1. The topic which we are discussing now is so the effects of oxidation reactions in everyday life. This is what we are going to study now, which is corrosion and rancidity. Anybody has any idea what is corrosion, rancidity? Have you studied this before?
Rusting is corrosion, sir.
Yes, rusting of iron is one of the examples of corrosion. Corrosion can be of any other metal also, and it can happen because of air, oxygen, moisture, acid. It could be happening because of multiple reasons. Corrosion can happen. Okay. So rusting of iron
Sir,
is,
so rusting and corrosion are not same?
see, rusting is one of the examples of corrosion. So what rusting is basically corrosion. Okay.
Yes, sir.
The name rusting, it has been given to corrosion of iron. Corrosion of iron is called rusting. Okay.
Yes, sir.
And then, have you heard of rancidity?
No, sir.
Okay, let's learn that today. Okay, I need a volunteer. Who will read this for me?
May I, sir?
Yes, go ahead. Yes.
Have you observed the effects of oxidation reaction in everyday life? Corrosion. You must have observed that iron articles are shiny when new but coated with a reddish brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of the coating formed on copper and silver? When a metal is attacked by a substances around it such as moisture, acids, etc., it is said to corrode and this process is called corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damages to car bodies, bridges, iron railing, ships, and to all objects made of metals, especially those of iron. Corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. You will learn more about corrosion in chapter 3.
Okay. This is just a high-level introduction to what is corrosion. And just now you saw corrosion can happen to multiple metals. Okay. Like for iron, what happened when rusting happens? We call it, when corrosion of iron happens, we call it as rusting. And what is the color of the substance that is formed in rusting?
Reddish brown.
Reddish brown. So these things you have to remember, reddish brown color. Okay. And then silver and even copper. So for silver, when it corrodes, what is the color? There's a black coating.
Black.
And about copper, it's green coating.
Green.
So you need to remember these colors. Okay. For For iron, it's called rusting, and the color is reddish brown. For silver, it is black coating, and copper, it is green. And as you know, this you'll be already aware of, corrosion can damage. The car bodies, would have seen some old cars kept besides the road somewhere here and there. You would have seen that how the body gets damaged because of corrosion. And government has to spend lots and lots of money to replace the iron which is used in railway tracks or bridges to make sure that they don't get damaged. So it's a serious problem actually.
So galvanization won't be done, sir.
Yes, yes, there are ways to solve that problem. Instead of using the pure iron, we can use alloy, or if we have used iron, we can put some coating by doing some basic coloring. If you color it with some substance, then it'll not be exposed to oxygen in the air, right? Then there'll be no more corrosion. That is one way of doing galvanization. What is that? Do you know what is galvanization?
Mixing of some other metal that won't corrode with iron.
Yeah, so you will study that in the third chapter in more detail a little bit, okay? So that's why I will not go into that right now. Once we have studied the third chapter, then it'll make more sense that time, okay? Let's keep it simple for now. Just understand what is corrosion and remember these three things: iron, silver, and copper, and the color of the things when that happens. Okay. So let me give you the definition. What would you write for corrosion? Okay. We discussed that. This should be clear to you already. Remember that rusting of iron is a redox reaction. I'll give you the reaction also. Okay, so what's happening here? Iron is there, oxygen is there, and there has to be some amount of water. So yeah, you see I've written 2x over here. So this depends on how much amount of moisture is there, and that will decide how much amount of water will be attached to this oxide of iron. Okay, the iron 3 oxide. And the dot in between, remember, this is not a plus. This water is not added. This is not separate. Okay, this water, it is attached to this molecule. That is why you write it like this with a dot. And how many molecules of water, that is represented by the variable x. So just write that as a variable over there. No need to worry about that. It can, depending on how much moisture is there in the air, it can take different amount of a different number of molecules of water. Okay, but the idea is like this: iron, oxygen, and water, they combine together to give you iron 3 oxide, and it is hydrated because it has some amount of water attached to it. That's why you call it as hydrated iron oxide, which is rust. Just a minute. Okay, so we'll study about this in more detail in the third chapter. Okay, now let's read through the rancidity part. Someone else want who will read? Volunteer?
Can I, sir?
Yes, go ahead.
Rancidity. Have you ever tasted or smelled the fat or oil containing food materials left for a long time? When fats and oils are oxidized, they become rancid and their smell and taste change. Usually, substances which prevent oxidation, that is, antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers helps to slow down oxidation. Do you know that chips manufacturers usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxidized?
Okay. So this rancidity and corrosion, both you are studying here in this chapter because they are all result of oxidation of something. Okay, when the oxygen present in air, normally they will react with the oxygen present in air because no one wants to corrode something or make the food taste bad. No, so no one will provide oxygen in a laboratory. So normally this thing is a bad thing, so they happen because of exposure to the atmospheric oxygen. So when a metal is involved, metal gets oxidized, you call it corrosion. But when some food gets oxidized, what do you call it? Rancidity. So this is, in simple words, just food getting oxidized. So when I say food, it's not the everything in the food. Basically, the fat or the oil, whatever you have, that gets oxidized. Okay. So the food getting oxidized, that is what is called your rancidity. And then there are some ways to prevent it. You will see that. Okay. So let me write down the definition, what you will write if you had to answer this. So, okay. I say. Okay, guys, I'll do one thing. I'll simplify this definition and I'll write it for you people, and I will send it to you today. Okay. Uh, that definition, you should understand. This is just the oxidation of fat in the food, and it is. How do you understand? How do you recognize that food has gone bad? By the bad smell of it, right? You get a smell. So I will simplify the definition. The definition which I have right now seems a little complicated. So I will simplify and write it down for you people. Uh, let's just go through some ways to prevent this rancidity. So as you just now read, one of the ways to prevent it would be adding antioxidants, right? So just the name suggests antioxidant. What does it do? It prevents the oxidation, prevents the oxygen from getting attached to the food and making the food bad. So adding antioxidants will prevent the rancidity. But doesn't mean that when you add an antioxidant, it will never get oxidized. It just prevents to a certain extent. So I'll give you some examples, even though you don't need to remember it. But let me write down the names of some common antioxidants used in the food industry. So called BHA and BHT. What is that BHA? Butylated hydroxyanisole. That is the full form. Don't need to worry too much, but don't try to understand this. This is just an antioxidant, okay, which is used in the food industry. So you might take some packaged food products, and you can see that one of these will be mentioned in the packaging, that it is antioxidant added is BHA or BHT, and sometimes they'll be antioxidant free. They will say that no antioxidants are added, because nowadays people don't prefer those chemicals. So BHT is hydroxytoluene. Okay, so that is one of the ways to prevent rancidity. What else can we do? Like if you have some chips packets, have you ever seen that the packet will be totally puffed, full with something? What do you think is filled inside that?
Nitrogen.
Yes, they normally fill those packets with nitrogen gas. Why? Because nitrogen does not react with something very easily. It's very doesn't react so easily. So So this, you would have seen this in potato chips. Anyone knows any other way? Very common way. Normally you keep the food in cold condition. When you reduce the temperature, there also oxidation reaction, any reaction actually gets retarded in cold temperature when the temperature is very, very cold. So that is why you refrigerate things, no? Keeping food in refrigerator.
Sir, what if we add more oil to the food? Then also it will be for reasons.
We add more oil.
Yes, sir.
So I think you are talking about something like pickle, right?
Yes, sir.
Where we add lots of oil, so it reduces the contact of the actual food particles, whatever you have, that they are not in contact with oxygen anymore. So that
Yes,
also,
sir.
yeah. So yes, our
Sir,
Indian, yes, tell me.
so preservatives and antioxidants are same?
No, I don't think so. They preservatives can be of different types. Antioxidant will just prevent the oxidation. But I'll see more details of that. I'll see what preservatives people add. There can be different types of preservatives. I will see if I find more information about that. I will do. Okay. So why do we keep things in refrigerator? Low temperatures slows down the oxidation process. Low temperature slows down the oxidation. What else? What else can we do?
Sir, I asked you that what if we add more oil to that particular food?
Yeah, that's correct. But you understand, right, that that is one of the ways for our Indian condition. We do that actually. For pickle, we do that. But we are not seeing that example here because pickles is something which is not so common outside. They don't even in outside they do some they dip their pickle in not in oil, but in some other thing like what is it called? So I'm forgetting the name of that thing. In foreign countries, they dip their pickle in some other liquid to preserve it from getting bad. So you are not seeing that example only because we can't put, if you have potato chips, can you dip it inside oil and keep it forever? No, right?
No, sir.
So this is not a very practical solution, but it definitely works for things like pickle. It will work, okay? Because it cuts down the supply of oxygen. The food is no more in contact of air. So of course that can be one of the way. But
Sir, that liquid looks like water, no, sir. Water and oil, like that.
yes, yes, yeah,
Is it vinegar, sir?
yeah. I think it's vinegar. Yes, they keep it inside.
Kind of vinegar.
No, they keep it in vinegar only. They keep it in vinegar. I've
It
seen
tastes like salt, no, sir. Something,
it.
not even salt, sir. It's something tastes like.
Yeah, yeah. It has some tangy taste, but depends. I've had some jalapenos, but they are by themselves they are a little bit tangy. So I don't know. It was because of the vinegar or because of what? But let's see. We don't care about all those things. Whatever, if you cut down the supply of oxygen or the air, that will be definitely one of the ways. Okay, so that is where the next point comes into picture: keeping your food in airtight containers. So when you keep something in airtight container, you are not exposing it to air. Okay, Nitya, that is obviously right. Okay, we can do for pickles. That is that is how we do, right? In our Indian culture,
Yes, sir.
we have been storing pickle for we keep stored for years actually.
Yes, sir.
Sir,
Yes,
sir, is there any food which can be like preserved for decades?
food can be preserved for decades. Something edible,
Yes, sir.
something edible. I have never seen that it is being preserved for decades. But something to drink, something like wine or something, they not even wine. There are some drinks which they keep it for fermented and they keep it for years and then still people drink it.
Sir, I have a doubt, sir. But to, but that's not related to this subject, sir.
Okay, almost we are done with the class, so you can ask me.
Sir, do honey expire? Yes, sir.
It will expand, no, sir.
Yes, honey is also a food, and if you keep it exposed in air, it will get. It doesn't get bad so easily. Not like other food. Not within 1 or 2 week or month. It'll. If you keep it for months, many months, it will go bad.
Sir, if it is spoiled means it will be liquid, no sir, or some other kind of color.
See, honey are of different types. If you there is of course there is some expiry date on whatever packaged honey which you buy. Okay, so you can't keep honey for a very long time.
Yes, sir.
Goes bad after some time. Okay, so the last point which is there, like you can keep the food away from light. That also helps to preserve it.
Sir, the place where there is no light, there is oxygen.
No, I mean when you keep it closed and if there is no light in that, absence of light also retards or slows down the oxidation process. Okay, to some extent. But if you keep something in dark, don't think that okay, tonight I will keep my food inside a very dark place and leave it, and then after 2 days I will eat. So it will not oxidation will not happen, but fungus will attack on it, and you can't eat that food anyway. Okay, so it has different problems, but just to stop prevent it from rancidity, these are the ways in which it can be done. Okay, like I said, I will give you the definition of rancidity and then I will send it to you. Okay.
Sir, do fungus attack when we put that food in airtight container also, sir?
Yes, depends on how much air is already there inside. If there is a moisture, if there is some amount of moisture, fungus can attack. Fungus will grow in that, even inside airtight containers. But if it is airtight and you have sucked out all the air from there, then the chances of getting fungus over there will be very low. Depends on what you are storing. Something wet means fungus will be there. If it is something very dry and you take out all the air from there and then make it airtight, then fungus will not grow in that. Okay. So with this, we have completed this chapter. So what I will do,
Sir,
yes, tell me.
the food can be preserved in vacuum, right?
Yes, if you keep food in vacuum, there will be no air to react something with. So it can be preserved for certain amount of time.
So how long will it be?
I have not tested that. See, I think that potato chips, they are putting nitrogen gas. Instead, why can't they make uh, take away all the air and put vacuum inside that? I mean, make suck out all the air and create vacuum and preserve it for a long time.
Air,
Mhm.
the pressure from outside will crush it.
Yes, that is one of the reasons, of course. Like if you take away all the air out of it, first thing, the biggest problem to maintain vacuum is not so easy. Even if a small cut happens during packaging or something, air will go inside, and you will not know. The people who are buying that product will not know whether this thing has gone bad or not.
Yes,
But
sir.
but
Even
if you
basic
but yeah, so you would have seen that they always instruct you that whenever you are buying some packaged food like chips, they will ask you to uh, check the packet
check.
whether it's leaking air or not, because if it is not puffed like it is intended to, then you should not buy that. If it is cut from somewhere, then you should not buy that packet. Okay.